Let us now have the effect of earth plane to the capacitance of transmission lines. Okay? So, you try to imagine, no, yung transmission lines natin are expanding from one place to another, di ba? Nakalatag on a terrain. Of course, from a certain height, no? From the terrain. Okay? So, in this case, it is assumed that the earth has effect on it, no? Because of the presence of the electric field, okay? No? Of the earth itself. Okay? So, kasi nga, there's an assumption that the earth is a conducting plane. Okay? So, the presence of earth is altering the electric field of transmission lines. Okay? Specifically, affecting the capacitance. Okay? So, look at the figure here. So you have the earth plane here. Okay? So, this is your conductor. Okay? So, there, since yung conductor, yung earth plane nga is considered also as a conductor. So, as if the positive charges, merong equivalent negative charge. Yung field lines are, of course, traveling from the positive charge, okay, the field line, as denoted, no, by the arrow, going to the negative charges. So, doon siya nag-terminate, no, from positive to negative. Okay? So, in the calculation of capacitance, so the earth may be considered or may be replaced by sort of charged conductor below the surface of the earth. So, ito yun. Okay? Yan. The distance will be like equal, of course, no? So, as if itong positive charge conductor mo is a reflection nitong negative charged conductor mo that is below the surface. Okay? So, if this is H, because this is H. Okay? Yan. So, the assumption also is that the conductor has the same, the charge, the true charge has the same magnitude of the charge, no? Equal magnitude nitong fictitious charged conductor mo that is below the surface of the earth. Okay? So, that process actually process is actually called image conductor, or the process is the method of images. Okay? So, yung conductor, yung overhead conductor mo, nag-mirror, meron siyang image conductor that is below the surface of the earth. Okay? So, that's the effect of earth plane. Now, because you do have now two charges, okay? So, isang positive, one that is negative, which is a perfect image of your true conductor, no? The image conductor, no? Yung true conductor mo has an image conductor, okay? Which is the fictitious one, okay? So, of course, the line-to-line capacitance, okay, merong effect yun, no? So, in the case of single phase, okay, single phase muna tayo. So, it is pi e or epsilon over ln of tr minus ln of xyxx. Okay? So, please don't be confused, no? Hindi ito yung hxy. It's a big no-no, no? So, hindi yan yun. Okay? instead, it's here, no? HXY, okay, and HXX. Okay, so because method of images, so we are taking into account the image conductor of the overhead conductor. So what we are taking into consideration here is your HXY, or the height or the distance between your true conductor and the image conductor. And in this case, yung this conductor to the other conductor, okay, over this conductor dun sa image niya na conductor, HXX. Okay, so this might be new kasi walang ganito in inductance, no? Okay, so ano lang, you just have to always remember, we are deducting or subtracting the effect of the mirror. Okay? So, di ba, ito naman yung original. Pi E over ln of dr. So, we are just taking into account, okay, yung effect of the image conductors. Okay? So, there's a note here, no? So, the effect of the earth plane is to slightly increase the capacitance. Okay? Akala ko ba mina-minus? Yeah, we are taking into consideration this. Pag bininus mo to, so meron siyang inverse relationship kay capacitance. Okay? So, nag-minus ka dito, lumiit, and then you'll have a slightly increase in capacitance. Okay? Yeah. And also, take note that as the line height increases, ito yun, the line height increases, the ratio of this image conductor, no, when that one approaches 1, as if the ln becomes 0. So, the effect of earth becomes negligible now. Okay, so, say you have the conductors here, so this is your CXY. And then when you increase the height, so andito na siya, so the effect of the earth will be now negligible pag tinaas mo na siya. Okay? That's for single phase. Okay? Now for three phase, okay, three phase. So we have phase A, phase B, phase C. Pwedeng flat horizontal din siya na three phase. Pwede ring equal spacing, pwede ring not equal spacing, no? It depends on the conductor configuration, no? So in this case, so three phase na siya. So we are considering now our DEQ here. So equivalent na, okay, DEQ GMD. Kasi three phase na tayo. So we're considering three products of the distances, okay? And here, it's a new one also, no? So, di ba, dun sa single phase, you are considering the effect of the height nung conductor, the true conductor, okay? Kinuha natin yung height niya, true conductor, and then its height, its distance from the true conductor to the image conductor, no? So, it's the same thing here, no? So, where's your H12? So, for example, this is yan, H12, no? Then, another is H23. Okay, in this case, H23, and then H31. It's sort of DEQ. Kaya parang DEQ yan eh, no? 1, 2, 2, 3, 3, 1. Okay? Yan. And then, after that, yung H1, H2 natin, no? So, yung vertical, the vertical distance, okay, between the image conductors. The true conductor, image conductor niya, itself, parang gano'n, no? Self yan. Kasi, it's always GMD over GMR. So, yung GMD nito, like what I discussed. And then yung GMR, okay, edi ito, yung self, 2, 2, 2, 3, 3. Diba? Those are H1, H2, and H3. Okay? So, effect of earth plane on capacitance, single phase, three phase. Okay?